we got just a couple of minutes before this session starts. You guys having a good time? Y'all prepared for this? I'll go ahead and tell you a little bit about this speaker. This is my dear friend, Paul Coggin. I have the job I have today because of this man. I've learned a lot from him. He knows more than I will ever be able to learn, forget, and relearn, especially when it comes to networking. Just when you start to get comfortable with networking, he shows up and shows you how to do it the right way and tells you how you've been doing it wrong. So this is Paul Coggin. He's a Cisco whiz. Just good old, we call him Bubba. When you hear him talk, you'll know why. Just a good old Alabama boy. But he's the best. Honored to call him friend and glad to have him here. So without any further ado, it's all yours, man.
Thank you, Jim. Appreciate that. Thank you, everyone, for coming here to hear my talk today. Like Tim said, my name's Paul Coggin. I'm a country boy from Alabama, old school network guy. Started in IT in 1994 and got into routing, switching in 97. Been involved with network architecture reviews, penetration testing, figuring out how to break into the network since 1999. And so I try to go and present on the lessons learned I see out real world. Whenever I go out to networks and do a project and I see some really bad mistakes, I create a slide in their honor, so that I'll remember and I can go and share with you something I've seen that we need to go clean up in our networks. So this penetration test presentation has got some blue and some red in it. And I'm going to get into some things and some old school basics. Any of you guys got a lot of network background, CCNPs, CCIEs in the room. This will be some old school stuff for you, old hat for you. But I'm seeing with a lot of the red teams, the penetration test teams that I go behind, that they're missing some of these things. Just some old school stuff. Everybody's looking at the web app stuff and the mobile, which needs to be hammered because there's a big surface of attack there, but we're forgetting where we come from. And we need to go back and hit it according to some of the pen tests I've been on here in the last couple of years. Because literally, I was on a pen test not too long ago, and the pen test was about to be wrapped up, and I just go in and fire up Wireshark, and I am not joking. There's no exaggeration. I find 6 to 8 high-level vulnerabilities, Cat 1 vulnerabilities, and it takes more time to fire up Wireshark than it does. And then you just fire up Wireshark and you just start seeing them just pop up on the screen. And there's already a big report ready on, all the web apps, all the other, sensors and things that had issues. And the network's got Brocade, the network's got Cisco, the network's got Juniper, it's got all, you name the vendors, it's got it all. Different contractors, different network guys, and they're all making the same mistakes. And so this is what we're going to try to go and get down to the brass tacks of some of these network problems that we're seeing here at layer 2. Because most of the pen test teams right now are focusing on layers 5 through 7. We're looking at the SSL, we're looking at the client server applications, we're looking at the web apps, and that's a big surface of attack that needs to be addressed. But there's this whole OSI model, those 7 layers. We don't need to forget about 1 through 4. And what we're going to talk about in this presentation is primarily layer 2. In the blue team, you guys, the defenders, this is for you. We're buying the Brocade, we're buying the Juniper, we're buying the Cisco switches, we're paying top dollar for the most expensive blinky lights we can put in our clown closets. We're getting the certifications, we got this stuff racked up, it looks beautiful. I don't know why we're buying it. We might as well buy unmanaged switches because we're not using the features that we're paying for. Because we go in to do a pen test engagement, and Windows is totally patched up. There's no vulnerability. You could have core impact, got a license for Canvas, you got all the Metasploit stuff updated, and you can't get into Windows because the guy's done a superb job. He saw you coming, and he's locked his Windows network down. When nothing else works, all you got to do is fire up Cain and Abel and Ettercap, go old school on them, and pull out a vulnerability from the 1980s when ARP was created, and you own that big network in a few minutes. It is crazy. And basically what's happened there, if you're don't have a lot of network experience, is, we're going to, when your devices want to communicate, they're going to send out an ARP broadcast on the network to map their IP address to the MAC address, and there's a promiscuous trust relationship out on the wire. And the devices are going to respond back who owns that IP address with their MAC address, and everybody sees that broadcasted out on the wire. And there's a thing called a gratuitous ARP where even without there being a request for who owns this IP address, what's your MAC address, you could go out and poison the ARP cache by just flooding the network with gratuitous ARPs and mapping IP addresses of interest to your MAC address. It's very simple to do this. And you could do it with a tool, say like Cain and Abel if you haven't done this before. I like to do the Cain and Abel because it's got real nice colors, and management likes nice colors in their PowerPoint slides. Because it's all about the PowerPoint. If you don't have a screenshot with PowerPoint, it didn't happen. You got to have a screenshot. So here's an example of where we did Cain and Abel, and we captured somebody's login into their router. In this case, the password's almost always Cisco or San Fran, whatever they learned in their network class. But so here's another problem we see. It amazes me that in my previous position where I was doing consulting, running around the world doing network consulting and training, it was amazing that at least a couple of times a year I would see somebody's network get attacked by a rogue DHCP server by some insider. Might be some contractor, some employee that went and took a class and bought a book at Amazon, off Amazon, or on how to hack, and they go and fire up a rogue DHCP server, and then you see the IT guys running around doing the Keystone Cop maneuver. And like I said, they've got the Brocades, they got the Cisco, they got the Juniper switches, they got good managed switches, but they don't have the basic features turned on to go and secure layer 2. And all we'd have to do to shut this down is set up that we only trust the DHCP server to allocate DHCP addresses and respond, and make all of our access devices untrusted and shut them down. Why would we want our end users, any roaming users, any mobile users, to be able to act like a DHCP server? Create a template for your access switches and shut that down. Just kill it, make it a template, kill it cold. But here's a trick for you, something that you may not have heard of that we use from the service provider world that I really want you blue teamers to know about. Because you go into some networks, God help them, they still want to do statics because they don't like DHCP and they only trust statics. I don't know how you manage a network of any size in today's times with all these mobile users with statics. If you want to continue not having a life, go for it. But here's a way to go and get real good security with DHCP so that you know where users are coming from when they get DHCP. There's a capability called Option 82 in the service provider world, where I was out building telco service providers for cable modem networks and DSL, fiber to the home, etc. We'd have when the federal agents come in with a warrant and want to be able to look at some users' traffic, the telco's got to be able to provide that information to the law enforcement, or it's a $10,000 a day fine. Well, how do they know that they're giving you the correct traffic, that some user, this is the IP address that they had on this day at this time, and this is who it was, and it wasn't someone else up the street that's fixing to get their door kicked in at 3 in the morning? Well, how they do that, if they're not using PPOE authentication, where when you authenticate, you get an IP address allocated to your user account, they use DHCP, and they use a capability called Option 82, where when your device, when your home network, your business requests a DHCP address, the device that's aggregating all of the subscribers, it injects into that DHCP header the name of the device. Say it's maybe it's a DSL DSLAM or a CMTS, a cable modem termination system, basically a cable modem router. Whatever device is aggregating those users that first hits first receives that DHCP request as it heads northbound toward the DHCP server, it injects in there that name of that device and the physical interface it's coming from, along with the MAC address as it heads north. And so when the DHCP server receives that, it has all that information to log. So then they can go correlate that back to their billing system, that they know that your physical interface on that device is in the billing system, and it ties back to this customer's address. Well, that same capability is built into your enterprise switches. Your Cisco switches, your Juniper, your Brocades, they're going to support this option 82. You just got to turn it on. And for years and years, Microsoft did not support this in their DHCP server. You had to go get something like Cisco Network Registrar or Infobox, DNS DHCP server, or you could use the DHCP server on Linux to get the option 82. But now Microsoft supports the option 82. If you're not aware of it, go out to almost all you guys probably use a Microsoft DHCP server. Go out there and check that out. This is a way to know that you know where that IP address was located physically on your network when they started doing something for those internal users. They'll help you out with doing your forensics and network monitoring, that you know where they physically, especially you guys that have really large campuses, universities, and large businesses that are spread out. Capability I want you to know about. I wish I knew about it when I was doing enterprise networking. I just tripped across it doing service provider over the years. Here's one. Spanning tree. Man, I see this take down some big networks. I've seen this take down some large networks, large manufacturing operations, some major Keystone Cop operations going on when this gets attacked. Why would our end users need to see span tree? Span tree protocol is to get rid of loops. A engineer, developer named Radia Perlman developed the spanning tree algorithm. I believe when she worked for Digital Equipment, I believe it was when she developed the 802.1d protocol originally, many years ago. And it was designed for bridges, now switches. Why would our end users need to see spanning tree? We don't need end users trying to interact with a switch protocol. But you fire a Wireshark and you see it. And what you're probably going to see in many cases, because Cisco's got the market share, you're going to see in your Wireshark, you're going to see a default priority of 32.768. And you guys that are doing network architecture reviews, audits, pen testing, you see that 32.768, that automatically trigger in your mind. That's a free piece of intel that they're a Cisco network most likely. And then you can start thinking in your mind, okay, how am I going to go and audit? How am I going to target, evaluate this Cisco network if you see that 32.768? But from a defender standpoint, why are we going to let our end users see this? We should kill this on our access devices and not let them interact with this protocol. Now, from a pen test standpoint, if you're out there working as a consultant, as an auditor, you're probably not going to want to go target this, because I started doing auditing in 1999 when I first worked on my first network audit, and I've done it for everybody, every kind of .gov, .mil, .com, .net, .org type of organization, and I've never been put under contract to do a denial of service. You light up that help desk, project's over. It's over. Everything stops, and then your project manager's going to be very upset because the billing stops. Then you got to go figure out something else to go put your time against. And that's what you're scheduled for. So we don't want to go and do a DOS. So we're going to probably go and just pull up Wireshark, discover spanning tree if we're out there doing consulting engagement, and explain to the customer the threat of what could have happened. And what could happen, we might go and pull a lab together and mock up and show a customer. You could go and pull out a tool like Yersinia that comes on your Kali Linux distro and your backtrack. You could use a tool like Yersinia, for example, and start sending out BPDU frames. And those BPDU frames are going to be going out every 2 seconds, and you could go, instead of sending out a priority of 32.768 like the Cisco's will by default, you could go in and bump down to, say, a priority of 1. The lower the priority is what's going to take over the root bridge function for the network. Because with spanning tree, it's going to do an election to see who's going to be the root bridge, and it's going to try to determine the topology and get rid of the loops in the network. Well, if they left everything as default, like most of the networks have that I see, there's nothing to stop an adversary, a rogue user that just wants to torment the network guy, because you turned off the like I did to an IT guy one time, was spending too much time on fantasy baseball in one of my many previous jobs. You go and aggravate that guy, take away his fantasy baseball, he might go and fire up, boot off of a Kali Linux, fire up your Cine and start knocking your network out for you intermittently, make you real popular with the C-level staff. Didn't happen to me, but I'm just thinking as there's a scenario for you. So what you want to do from a blue team standpoint, you want to go in and you should go and turn on span port and so span port would get rid of the BPDU frame going out to the end users because they don't need that anyway, and it would make their computer come on the network faster because it doesn't have to go through the span tree algorithm when they boot up on the network. And then what you want to do is turn on BPDU guard so that if anybody starts sending BPDU frames on that switch where you don't expect it, that you could kill that interface, make them call the help desk and explain themselves. So, because one thing that happened, they either fired your Cine up on you, or most likely what they've done is they brought in a rogue access point, one of these little Ethernet switch / router / microwave devices they got at Best Buy or Fry's or what have you, and they fired it up on the network. Because one thing you do, if you turn on that BPDU guard, you got a span port over where they don't see span tree, and you turn on that BPDU guard, you got your root guard on, most likely what you're going to catch is rogue access points. It won't be that you're sending somebody crapped in frames. You're going to see an Ethernet switch, and that Ethernet switch is going to be probably a rogue access point. Just such a free piece of consulting for you there. But also what you want to do is on the switches that your core switches, like in your data center that's aggregating all of your comm closet, put on those core switches, put on the root guard to protect the root switches for your network. So here's something else that you see. Friends don't let friends do auto negotiation. If you run a network, do not do auto negotiation. I have seen a lot of network guys lose really good jobs unnecessarily, or come very close to losing really good jobs because of auto negotiation, and it's ridiculous. Go in and hard set your switch configs, get rid of the half duplex, lock in the speed, get it all, full, and lock in the speed, get rid of the negotiation, and if there's trunking, if you need the trunk, if it's a device, switch to router, switch to switch, you need trunking, hard set it, but if it's an access device and it doesn't need trunking, don't turn on the trunking. The only access points that you're going to need is going to be maybe a wireless access point or your voice over IP phones. You might need trunking, but your end user shouldn't be able to go and interact with your switch with a trunking protocol and try to negotiate that. And also go in and change those default VLANs. Change that default VLAN from VLAN 1, because everybody, they can go and pick up a book, read a white paper in a quick Google search and figure out, hey, the native VLAN is 1, and how to, be able to try to go in and attack your trunking. So change that VLAN to some other VLAN number, and maybe somebody is trying to attack your trunking. They'll create some noise and you'll catch it in your syslog. Wrong slide. So, what would you do with that dynamic trunking, for example? Well, one thing that you could do, you might have heard of VLAN hopping. You could take your Cine again. Your Cine is just pure evil for layer 2 attacks. A gentleman out of France developed your Cine for his thesis a few years ago, and it's a very good little tool for attacking layer 2 real quick. If you're not good with Scapy and crafting package, if you're not a Python ninja. And so in this case, we might be plugged in to a switch. We're tight, we're associated with VLAN 10. But we could take something like Yersinia and do VLAN hopping, and maybe we could go and double tag our traffic, our Ethernet frames. We could go in and double tag that VLAN and add, say, VLAN 40, and not only go up to VLAN 10 that we're plugged into, the switch peels off VLAN 10, and then we're able to go and throw a packet into VLAN 40. The key here, from a pen test standpoint, you're only going to be able to spike traffic in one way. You're not going to get a two-way connection. But I've been on numerous pen test engagements where we were told you're not going to be able to get traffic into this network because I said you can't. Because I got VLANs. Oh, really? Oh, really? You know, all sometimes you got to do is be able to spike a packet down the wire. And if it's inside your rules and engagements, you may want to try that. And the scenarios that I've been in, the customer did not want us to go and prove that we could do it because we figure out a denial of service attack where if we could just spike the right kind of packet down the wire, we could maybe crash that system. And so we would go and fall back and do a proof of concept in the lab, and we would go and fire a Wireshark on both ends. Here's the packets, here's what we're crafting, here's where we're sending it, here's where you're seeing it on the remote end to prove the concept where we can all have an adult conversation. And let's go work on the mitigation instead of arguing, the way we want it to be. This is a scenario for you. Another one, I've never done this on a test, but it's something that your blue teamers need to know about. The pen test team, the red teamers, you're not going to do this most likely because it could cause a denial of service, and we don't want to do anything that may possibly blow up somebody's switch and cause a performance issue and light up that help desk. But we need to go and look at limiting the number of systems that can connect on an access port. Why would somebody in the cube need to be able to generate thousands of MAC addresses? Give them 10. Maybe they got maybe 5, however many. You know, if they got IP phones and maybe they have multiple devices in their office. But we should go in and limit the number of MAC addresses that we expect to see from those user ports, so someone can go and try to go and blow up our MAC table and make our switch revert to acting like a hub. Depending on what switch you're using, you may not be vulnerable to this, but let's just take it off the table for someone from even attempting to begin with. And we'd want to go and turn on syslogging and have our SNMP send alerts proactive in case someone attempts to do that to us. We could set up, at least on the Cisco's, you could go and if somebody violates that trust, you could tell it, to send an alert or shut the port down. I'm all for shutting it down and make them call and explain themselves. Because you already know what the problem is. Hopefully you got syslog going, you got SNMP trap alarms happening, and you can call your boss and their boss in HR and have a really interesting conversation about why you're seeing this all of a sudden. So here's another protocol we need to talk about, this BTP, the VLAN trunking protocol. You're going to see this primarily in the Cisco networks, where you're going to have a centralized server where you're going to create all your VLANs, set up and define all your VLANs, your VLAN numbers, give them names. God help you, please, in case I have to show up on your network, put a name on the VLAN so I know what VLANs are voice and what VLANs are video surveillance, etc. But you're going to set that all up on your BTP server. And then you're going to have trunks down to your other switches where they can receive the VLANs that they need to receive so that you can provision your users. And that's going to be the client. And that all works real great. But the problem is we all go to class and we all learn how to do this and we're all happy and we get our certifications and we don't think about the security implications. And everybody goes and sets up the defaults. They name their domain Cisco, or they name their domain after their organization, and they have a password of Cisco or San Fran or the name of the organization. Some, basically like a default or nearly default domain and password. And then either somebody maliciously or accidentally, just not thinking, they'll go off and take a switch out of the lab that's being used a great deal. Maybe you've been doing some certification studies. You've been changing the configs on the switch all the time because you're getting ready to test out. And all of a sudden you have a switch die. Maybe you had a lightning storm come in and pop the switch. And now you got to pull that switch out of the lab. You got to go throw it into production. That switch that you just pulled out of the lab has a newer VLAN database. The VLAN DAT file that holds all the VLAN configs is newer. You plug that bad boy into your network, next thing you know, you've lost all your VLANs. That help desk is fired up like a Christmas tree. All your management, people you didn't know, all the way up to the nosebleed section of your org chart, you get to meet them all. Because they're all coming looking for you. Because you just wiped out the whole network. You've lost your voice network, you've lost the video network, you've lost internet, because you plugged in a switch, it's got a newer version of that BTP database, and it's synced up because you had the same domain and the same passwords, and it syncs up, and it gets overwritten. I can give you this slide because I've seen this happen to a few people. And it is a scary thing because a lot of people have a backup of their router configs and their switch configs, If they forget about that VLAN.dat file, your VLAN configurations, at least on the Cisco, are not in the config. They're in the VLAN.dat. And, oh, brother, you talking about watching somebody sweat when they start trying to remember their VLAN scheme and where all the VLANs were on the network when that happens. From a consultant standpoint, I'm there by the hour. I'm good. I'm there until we can make up VLANs. We'll get it all rebuilt. So I get paid by the hour. You know, but for the guy who owns the network, it's a bad deal. So you want to go and make sure you got a good backup of your VLAN.dat if you're a Cisco shop or whatever your counterpart is, whether you're Adtran, HP, Cisco, Juniper. But also make sure that you change those defaults and you have good passwords. I mean, this could happen to you if you were to go use a switch that you got off refurb, or you bought used off of eBay or something. Plug-in that could happen to you. Here's another one that's getting overlooked by everyone. Nobody's looking at this. It's ridiculous. This capability's been out forever. How many people over your career, if you've been in the network business for a while, you've had a network get knocked out by jabbering Nick? You know, I'm in Alabama. I used to work at a place. It could lightning in South Alabama, and it would knock out our network in North Alabama. I don't know. Something would happen, and something would start losing its mind. Some transceiver, NIC card, it would start jabbering. This was back in the days we had big flat networks, and it would take out the whole network. But I've also seen, because I work where I work in the city where I live, a lot of engineers doing research and development, developing network applications. We'd also see the developers develop multicast applications or some other crazy network application. Trying to do real work. The guys are trying to go and solve other customer problems. Very, very important problems. Doing what coders do. They test their code. And they're learning network. They may know everything about Java and C, but they're not network gurus, and they're playing with learning networking as they learn their code. And they accidentally create a broadcast storm or a unicast storm or a multicast storm and tear the network down. And what's crazy is they would call us and we'd show up, and they had the nice managed switch blinky lights, and didn't turn on the ability to limit storm control on their network, so that end users, if a piece of hardware went bad and started jabbering because hardware fails, or say if lightning popped it or what have you, it could cause that failure, or if it's a developer that's created some crazy rogue application, starts spewing traffic, they wouldn't knock out their network. Here's a real world application where this should have been used. Back in my backyard where I live, near and dear to my home, there was a nuclear reactor back in 2006 that they had to do an emergency shutdown at TVA. I think the article I read was August 2006. They had an emergency shutdown in a nuclear reactor because of excessive Ethernet traffic. And if the blinky light switch they had was turned on to do this broadcast storm control, could have stopped that. Since that thing is less than an hour away from me, I would greatly appreciate it if that was turned on. I was alive in 06. It could have got really hot in North Alabama if that thing went the wrong way. I'm just saying. And so here's something I see, guys. I'm seeing this all everywhere. You go fire up Wireshark. If you're out there doing audits, go back to your home network, fire up Wireshark. If you're out there doing compliance testing, if you're out there doing pen testing, this is low-hanging fruit for you guys that are out there doing consulting and doing audits and testing. Low-hanging fruit. I see it everywhere. I was just in the network, and they had, like I said, they had the Juniper, they had the Cisco, and the Brocade. 3 different networks, 3 different vendors, 3 different manufacturers, 3 different consultants managing the network, and they had all 3 networks had this problem. The Cisco was running the HSRP, and the Brocade network was running the VRP, and the Juniper network was running the VRP. And what those protocols are for is redundancy. Because the smart IT guy is going to at least have 2 in case one fails. That's part of that whole salary continuation program, right? You lose one router, you got a second router until you get your replacement router in, and we can live to fight another day. Keep that direct deposit working, which is near and dear to my heart. But what you do is you're going with those protocols there. Is you have your redundant routers, and they're going to sit there and send a heartbeat between each other on those VLANs, and you're going to configure one of them to be primary, one of them to be secondary. The primary drops, the backup will automatically pick up, and they're sitting there multicasting on the wire. Wherever I plug in Wireshark and the network is of any sophistication and they have redundancy, if they have redundant networks, I always see this. I always see this when I'm out there doing audit. I just pull up Wireshark and it's there. Here's the thing. All those protocols offer you no authentication, clear text authentication, and a hashed authentication. They never use the hash. Never. Though it's an option. And they may go in and configure authentication. For the love, if you understand and you need authentication, why would you not use the hash? I don't get it. Why would you use clear? If you have enough understanding to know that you need authentication, why would you use the clear? Why not go ahead and encrypt it? But most of the time, you will see that it's not even authenticated. But if it is, don't worry, it'll be clear, so you can go and do this. It won't be a problem for us to go hack if it's inside your rules of engagement. Because this is what it's going to look like. In this case, what we have is in the black, we have 192.168.1.1 is a router, and then we got 1.2 that's a router in the red there. And they're sending their heartbeat between each other. And down there at the bottom, I have circled, you'll see a password like Cisco. And typically it's going to be Cisco, or it's going to be the name of the organization. It's going to be the password is going to be something relative to the organization that you're going to see out there multicast out there in the wire. And you would also be able to go and see the priority that's configured on the routers. In the case of the HSRP, the highest priority you could have to win this election of who's going to be primary and who's going to be the secondary backup is going to be the highest is 255. And you could go and do a quick Google search on VRP or HSRP, and it'll tell you how the protocol works and these parameters in detail. But in this case, we would see, for our conversation here, we'd see two routers. One of them would have a priority of 100, and one of them would have a priority of 110, as we see here. And if you're not a Python guru, if you don't know Python, you don't know SCAPI, if you're Windows impaired like me, if you're just router guy, you just use whatever tool is available and quick and easy. We could take that Wireshark capture. We don't have to be some Python, Linux, Ninja. You can be a redneck from North Alabama. It can double click Wireshark capture, download this nice little GUI, pull that packet into Colosoft Packet Builder here. Which Colosoft Capsule, by the way, is a really nice packet analyzer from some guys from a company over in China. Really cool tool for, but you can import your Wireshark capture, your PCAP, and what you see there in that blue line there is, where I'm going to go in, and I'm going to click on one of those packets, and with that Colosoft Packet Builder, you can just go click on the field in that PCAP and change whatever parameter you want to change. So I'm going to change like 1.1 or 1.2 to 50 because that's the IP address I got. I go and I change it to 50, and I go over and I change the opcode for HSRP to 1 because I'm going to go in and preempt and take over this conversation. And then I'm going to change the priority to 255. And then I'm going to go up there and click checksum, and I'm going to rebuild that packet. And then over toward the right, I can do a send where I can send the packet once, or I can do a send all where I get it into a loop. And he'll just continuously go and continuously send that heartbeat out. Those other routers are going to stand down, and I just took over as the router with my Windows box. I didn't write no code. I'm not no iron geek. I'm just a bubba that just knows how to download Wireshark and Packet Builder and import click, bam. I just took over my Cisco router, or I'm a Juniper router, or a Brocade router, or an Adtran router. Because it's sitting out there, just spewing right there. This is low-hanging fruit, guys, and it's being missed. I'm telling you. I'm going behind, you'll go behind very strong pen test teams with all the creds, and they will be tearing these networks up, and this will be low-hanging fruit. All you gotta do is fire a Wireshark, and you can start running up the score and get these findings. Now, here's the thing for you guys that are pen tested. You've got to remember this, otherwise you will accidentally do a denial of service against your customer, and then the project's going to be in a ditch. You got to remember when you go do this, on your operating system, to turn on IP forwarding to route the traffic. Otherwise, the OS is going to drop all that traffic that's getting redirected to you in the bit bucket. So you got to remember, if you go do this, because this hack works. This thing works. But you got to go in and remember to turn on IP forwarding, whether you use SCAPI and on Linux, Or if you go and use the Colosoft, remember to go in your OS and turn on the IP forwarding, and so that you can route it. And you're only going to get the traffic that's outbound. You're not going to get the inbound traffic, but all the keystrokes from that user you will be catching, like that telnet that they say that they're not using. Because they all say they're not using it until you pull up and do a man-mill like this and catch them.
Are you using one or two interfaces?
Just one.
Instead of a second interface?
You could. Dude, you get limited by your creativity and topology that you're connected to, how you're connected. Here's another one that's being missed. This is low-hanging fruit. The IPv6, whether they say they're using v6 or not, they're running v6. Every network I plug into, they all say they're not doing v6, and they're all doing v6. They just don't know it. Now you can go in and pull up your Wireshark and look at the Ethernet type 86DD, or you could go and just type in IPv6 and apply a filter, and you'll see all the IPv6 out on the wire. And then the network sysadmin, his jaw's going to drop. He's like, I didn't know that was there. And then most of the time the pen test team doesn't know it's there either because they're so busy hacking web apps that they totally miss this. And so what can you do with it? Well, with IPv6, we do not have broadcast. Your old school Cain and Abel and EtherCap stuff is near and dear to our hearts that we learned the first day of our first pen test class. Those tools no longer work for IPv6 because IPv6 is multicast. It's not broadcast. So EtherCap and Cain and Abel, you're not going to do the arc poison anymore. We're going to have to attack multicast. But luckily we've got some other tools that some gentlemen have written for us that work, and they work really well, like Chiron, Evil Foca. The THC Parasite 6 is good, and if you need to, you can go roll your own tool with Scapy, or use like Colosoft Packet Builder to craft packets if you want to. But what happens is one of the vectors is if you pulled Wireshark up on this network here, you would probably see some DHCP out there where those hosts are looking for a router because they want to learn the network prefix for the IPv6 network, because that's one of the features of IPv6 is stateless IP address configuration, where you don't have to statically set it, or it can do it statelessly, where the device is going to send out, hey, I'm looking for the router, and if the router is configured for IPv6, it will respond back with the network prefix for the network, and then your host device will take its MAC address, and in between the organizational ID and the serial number of the MAC address, it would inject FFFE, make it a 64-bit host address, and you append that to the network prefix that the router gave you, and now you've got you an IPv6 address, and you're ready to rock on the network. But most networks are not even configured for IPv6 internally, but they're out there looking for it. If we're doing a pen test, or if you have a rogue user on the network, or say a contractor or a vendor, depending on the business that you work at, what's to stop them from going and crafting packets and saying, I'm your Huckleberry, I'm your router, here's your IPv6 network number, and set up an IPv6 network for you, start routing and hook you up and start, and maybe they set up a tunnel out your firewall IPv6 and set up an IPv6 operation on your internal network, and you're not even looking for it. And so they could, and what they could end up doing is setting up a man-in-the-middle attack. But you can stop it. The vendors, the managed switches, your Juniper, your Cisco, your Brocads, they give you the capabilities. With the Cisco's, you got this RA guard. You could use 802.1x and authenticate users before they get on the network so that they know that they got some accountability. They're just not going and plugging in and anonymously into the network. They're going to authenticate, and you're going to know who they are and where they're plugged into the network. So this SYN, one of the things I'll call out with this SYN, a lot of, if you're not a network guy, you've heard of IPv6, and you heard it's got IPsec built into it. Yeah, an IPv6 compliant stack would support IPsec, but who wants to go and implement pre-shared key where you have to statically set a password on all your devices on the network, and then if you're under compliance, every so often you've got to go in and change all the pre-shared key on all your devices. I'm not signing up for that. And that's the reason I'm a router guy, because I don't want to touch those endpoint devices. I'll break out in a rash. I'll start touching the inside. I'll become a mechanic or something. Be a diesel mechanic. Go back to school. But the other alternative is to build a PKI infrastructure to authenticate. I personally don't know anybody that's implemented either one, but that's an option if you're going to turn on the IPsec if you want that level of security. And then there's a similar problem with the IPv6 that you need to be aware of to, again, turn on the port security for IPv6 on your network. Same set of tools can target and take advantage of vulnerability as you got the network discovery protocol. Because we're not doing ARP anymore. Again, we're doing multicast. So we're going to do network discovery protocol, and that's how you're going to learn networks. You're going to know how to traverse through the switch and resolve IP addresses to MAC addresses on your network. You're going to use this network discovery protocol. Well, that's going to be multicast out on the wire, and so we could attack it with Chiron and Evil Foca or TCP Parasite. Go check out ERNW. ERNW is a company out of Germany. These are some elite network guys. They create a great deal of network tools. And also check out Scott Hogg's paper on Evil Foca if you're interested in the IPv6 stuff. Some really good papers from those guys out there. Scott did a really good presentation on Evil Foca, and the ERNW guys, they're who I follow to learn about networking stuff. They're one of my main influences. Another thing I'm seeing out there on the layer 2, you guys are doing blue team. I know everybody's proud of all their firewalls. You know, you got your application firewalls, and we got our load balancers. Well, what we're seeing on pen test side, if we can get into any part of your DMZ, we can pivot freely and turn around and exploit trust relationships through the firewall into that internal network. We've got to go and start looking at locking down that subnet in that DMZ and building a traffic matrix of what systems need to talk to what systems on what ports and IP addresses, and we'll granularly lock down those trust relationships. I understand that it's not feasible to go in and re-subnet those DMZs because of you're afraid of what might get broken. Well, let's get some network visibility on this and build a traffic matrix and lock down that trust relationship very granular. And anything tries to violate that trust relationship, run it to ground and find out why. Something's either misbehaving, or we might have somebody trying to help us run the network. And here's how you get some visibility. If you haven't looked at it before, on your Cisco routers now, you can go and do packet sniffing. You can sniff traffic right off your router with a capability called embedded packet capture, EPC. You want to know about that, and a lot of you guys probably know about doing spam, where you can do port mirroring off the local switch, or RSpam, where you can mirror switch to switch. Another trick you need to know about is being able to go and mirror at layer 2, do port mirroring and point to an IP address. Maybe you got remote sites and you need to sniff and get visibility at layer 2. Well, you could take ERSpam and sniff across your wide area network, sniff local, do your local port mirror, and point the output to an IP address somewhere in your wide area network. And then, huge thing, you want to catch the bad guys. If you're not doing net flow, you have no idea who's in that network. You can tell me all day long all the stuff that you've implemented and bought. If you're not collecting net flow or JFlow or SFlow, whatever vendor's flow technology or whatever you've implemented in the network, if you're not getting flow, that metadata of who's talking to who, where, when, and how much, that statistical data, I really have little confidence that you have a handle on who's in that network. This is the other thing I want to recommend to you big time is who's watching the network guys. What if the network guy goes rogue? If you're working at a large enough network, you need a separation of roles and responsibilities. I recommend getting a TAP. Because I can tell you as a router guy, we're a very opinionated bunch and we're very territorial. My network, I'm the router bottle. I don't need anybody helping me run my routers and switches, and I don't want you to have passwords to it to go and mess up my BGP, OSPF, EI, GRP routing. It's my network. I'll give you what I want to give you in visibility. What if I go rogue? What if I were to go Snowden? Who's keeping me accountable and making sure that I'm not doing something wrong? Put in a network tap. It's an electrical bump in the wire, and take where you can go and do your port mirror and get a pristine copy of all the traffic off the network and send it out of band. Send it out of band to a network that only the auditors, only the security staff has access to. That way, we keep honest people honest. If the end users are not supposed to be abusing the network, who's making sure those router guys are not abusing the network? Just saying. Look at putting in taps. And like I said, go and look at, at layer 2, look at doing whitelisting of those trust relationships, get the flow of what's happening, and lock down that control management and data plane. When I talk about the control plane, I'm talking about device-to-device protocols, management, SSH. They shouldn't be doing telnet, but if they are, they better have it locked down, those trust relationships, SNMP. Make sure it's SNMP V3, don't use V1 and V2. If you have to, you better make sure it's granularly lock down that management plane, and then the user plane. And look at the control plane, management plane, data plane for each layer of the OSI model. As much as I would like to take credit for all that information there, this is where I learned it from. These are some of the references in the books that I learned and that I use when I'm out doing consulting and working. You can go back to and you can dig into the granular details. I highly recommend you look at the LAN switch security book at the very top. It's a Cisco Press book, what hackers know about your networks that you don't. Eric does a superb job of breaking down a lot of old school problems that are being totally missed. They're totally missed by the pen test teams and the blue team. The books have been written, the papers have been written, but we're not using them. Look at that. Look at Eno Ray and his team at ERNW. Their papers and resources. Yvonne and Scott's papers, some really good books and papers there for reference. So that's what I've got for you today. You guys got any questions?
Why would you ever want to enable source routing?
Source routing? I don't know why you would. But there.
Especially for merchant forms.
Yeah. Well, typically we turn off that on the routers that's typically disabled by default on your routers, at least on your Cisco routers. That's some old school stuff. You don't want that enabled. That loose source out route. You don't want that. Because you could go and craft packets and bypass the infrastructure. No, that's an old school problem. You don't want that.
Going to the auto negotiation and involvement, it's kind of a debate between people. I tend to from an environment that's locked down.
I can tell you, I saw a guy at a major university, a huge university, I won't lie say where, had an extremely expensive network. He had switches, top of the line switches, about the big as those doors. And he lost his job because of auto negotiation, because you get lock down the switch because you never know when you're going to get some bad drivers on your host and they're not going to negotiate correctly. And then what's going to happen is your network is, users are going to complain that the network is slow. Or if you're using like terminal applications like 3270 going back to the mainframe or AS400 or some kind of SSH or telnet application, they're going to be getting dropped connections and the villagers are going to be bringing pitchforks and torches to the network guys. I've seen a guy lose his job, had a wonderful job, and he lost his job because of auto negotiation. I saw another network almost back in 2000, almost sold $500,000 in Cisco equipment to a hospital. They was running Bay networks because of auto negotiation, because they were running 3COM 3C905Bs doing auto negotiation. Had a Bay network. It was totally okay. Wasn't nothing wrong with that network. But they were ready to rip the whole thing out because of these auto negotiation problems. And they had to go in, once they went in and hard set all the switches, even though the NIC cards had driver problems, they were able to stop it. And then you got the security problems of auto negotiation, like the VLAN trunking and things like that. Just kill it.
Is that on both sides, client and load?
Well, I'd hard set it on switches. Now, what they do on the desktop, you don't care about. I'm a network guy. I'm just taking care of my cloud. I'm taking care of my routers and switches. But those desktop guys, they can solve the problem. But I'm going to clean my stuff up. But if you lock down those switches, it'll probably fix the problem because it ain't going to negotiate. It's going to hard set.
Okay. So you recommend that on your core main access layer?
Oh yeah, I would lock it down. I would lock everything down. No negotiation.
I worked at that. They didn't believe in hard set stuff because you had that part flaked out a little bit. It would negotiate down to make it still have a connection to figure out the problem. So I've heard both sides of it.
Okay. Yeah. I'm the high priest of the salary continuation program. keep the direct deposit going, and I'm telling you, shut it off. They're telling me I gotta go. They're gonna tackle me, throw me on stage too.